So for this YouTube video, I'm gonna walk you through how I would solve each of the problems on the peer leading activity number 2. I want you guys to understand that many of the problems that you're gonna come across on these peer leading activities will show up on your exam this coming week. And so it's important that you understand not just how to do them by repetition and memory, but you understand what the question is asking and you're able to interpret it in your own words so that you can solve these problems and get them correct. So for the first problem, we're gonna work through what is the molar mass of Ba3PO4-2. So the first thing you wanna ask yourself is, what is molar mass? The first thing we know is that molar mass is in grams per mole, right? So we know it's a mass, and where have we heard the word mass before? On the periodic table, we have a mass number that sits under each element, and that's gonna help us quantify the molar mass of this entire compound. Because we know the mass of individual elements, but now we wanna take that entire compound into account. So, where can we find the mass of Ba? On the periodic table. And so when I look on the periodic table, I find Ba and the mass number is 137.3. But that's one of them, and here we have 3. And so what I'm gonna do is I'm gonna write this out very systematically, and this is exactly what you can do on the exam to ensure that you get the problem correct. So for Ba, I know the mass number, but we have 3 of them. So I'm gonna multiply the mass number, which is 137.3, and I'm gonna multiply that by 3. Now, let's move over to this polyatomic ion. In most cases, you're never gonna split up a polyatomic ion. But for these type of problems, when you're solving for the molar mass, you wanna look at each individual element to quantify the entire molar mass of the compound. And so we're gonna break up this polyatomic ion into separate elements. So first we have phosphorus, P. Again, we can find the mass of phosphorus on our periodic table, but how many do we have in this problem? You may make the mistake of saying just 1 because we don't see a subscript here, but you need to take into account that we have 2 entire units of phosphate. So, again, like we did for Ba, P is going to be 2 multiplied phosphorus' mass number, which is 30.97. Again, we're gonna do the same with oxygen. It doesn't have 4, but 4 times 2, which is 8. And so O has 8, and the mass number of oxygen is 16. So once we quantify each of these values, you just simply plug it into the calculator. And so 3 times 137.3 is roughly 411.9. 2 times 30.97, you're gonna get 61.94. And 8 times 16, you're gonna get 128. And so now that you have these values, you've figured out the mass of each of these elements within this compound. Now you just have to add up each of these masses together to give you the entire molar mass of barium phosphate. So 411.9 plus 61.94 plus 128. And you simply just have to plug that into your calculator and you're going to get 601.84. And remember, this is in grams per mole. Now, some people like to round at certain places and some don't. And so you may get different answers by maybe 0.1 or 0.2. It's a very negligible number. However, the exam is multiple choice, and so you don't really have to worry about significant figures that much. You should know them, but there's no way to test you on significant figures on your upcoming exam. So this is how I would solve question 1. Now let's solve question 1, part B. Question 1, part B says, how many moles of barium phosphate are in 60 grams of barium phosphate? For sake of time, I'm not going to solve for the molar mass of barium phosphate again because that is question 1, part A, but understand on the exam, questions are not going to be attached with one another, and so you're going to have to solve for the molar mass again to then use it as a conversion factor. But I'm just going to write what the molar mass was from part A. So the molar mass that we found for barium phosphate was 601.84 grams per mole. So to figure out how many moles of barium phosphate are in 60 grams of barium phosphate, we need to set up a dimensional analysis. Many times students will just rush through these problems, and as you get later on in the course, you'll be able to do these in your head just straight on the calculator. But for now, I want students to set it up how I'm getting ready to set it up, because it's going to ensure that you always get the question correct no matter what the question asks, because later on in the course you're going to be asked to set up multiple parts to solve for a specific number. So when we're going from grams to moles, we're going to use molar mass as the conversion factor. And so here's how you can set it up. You have 60 grams of barium phosphate, okay? And you want to cancel out this grams. In order to do that, you want the molar mass to be moles over grams. So you're going to multiply this. This is the conversion factor, but you want grams to be on the bottom. So we have 601.84 grams per 1 mole. So you see, we use the molar mass as the conversion factor, because what will happen now is we can cancel out the grams. And so now we're just left with moles. And so all you have to do is plug this into the calculator, and it's going to give you how many moles are in 60 grams of barium phosphate. And so if you plug that into your calculator, you're going to get some number that looks like this. And this is your final answer. So again, for these problems, when you're going from grams to moles, molar mass is going to be your conversion factor. Whatever your initial units are, you want to cancel those out. And so the only way to do that is if they're on opposite ends of the denominator. So one needs to be a denominator and one needs to be a numerator, because you can look at this as 60 grams over 1. And so the grams will cancel out, you're left with only moles, and so your answer is going to be in moles. And that is how you solve question 1, part B. Now we're going to solve question 1, part C. And question 1, part C says, how many formula units of barium phosphate are in 60 grams of barium phosphate? And so when students read this question, they get kind of confused because they see formula units and they've never seen that terminology before. But do not get it confused, because it's very similar to saying atoms, molecules, particles. And so if you look at your conversion sheet where you're going from mass to moles to number of particles, formula units is basically saying number of particles. But for when you use formula units, you're talking about ionic compounds. So we have an ionic compound here, and so formula units is the correct terminology, but treat it like number of particles. So here, we're going from mass all the way to particles. So if we're starting at mass, we can't just jump over to particles because there's something in the middle. If you remember your PowerPoint slide that has the conversion between each unit, you'll see that mass is on the left side, moles is in the middle, and number of particles is all the way on the right. And so before we can turn our mass into particles, we first have to convert our mass into moles. So question 1, part B did exactly that. But I'm still going to set it up again so that you can get used to doing that on the exam, because again, questions won't be attached to one another. So you're going to take your 60 grams of barium phosphate, and if you want to go to from grams to moles, what's your conversion factor? It's going to be molar mass, and question 1, part A, we solved for the molar mass of this compound, which was 601.84. So we're going to use that as the conversion factor to cancel out our grams. So you have 1 mole, right? Then we have 601.84 grams. And so this calculation alone is going to get us the 0.099 moles of barium phosphate. But it's not asking for moles, it's asking for formula units. So now we need to go one step further to particles. And if you remember, if you want to get to particles, atoms, molecules, formula units, Avogadro's number will be your conversion factor. And so we've canceled out our grams. Now we want to cancel out our moles. And so moles is going to be on the bottom and Avogadro's number will be on top. So if you remember, Avogadro's number is 6.022 times 10 to the 23rd over 1 mole. So this is the conversion factor that you should have set up to go from mass in grams all the way to particles, which is in formula units in this question. So if you plug this into your calculator, and make sure when you're plugging things into the calculator, especially when you have scientific notation, please put parentheses around that scientific notation or your calculator is going to spit out a number that's incorrect. If you have struggles with using the calculator for these type of problems, I will post a video on the best way to utilize your calculator for these type of problems. So you plug this into your calculator, and the number that you're going to get is 6.00 times 10 to the 22nd formula units. And this is how you solve question 1, part C. Now we're going to discuss question 1, part D. And question 1, part D says, how many moles of oxygen are present in 60 grams of barium phosphate? Now there's a few mistakes that students make with these types of questions. Whenever you come across these questions where they're asking you to pull an element out of a compound, please do not treat oxygen as a singular substance. What do I mean by that? Don't just go on the periodic table, see that oxygen has a mass number of 16, and we know that we have 8 of them, and you multiply 16 times 8 to get 128 and use that as a conversion factor. Whenever you're solving problems, when they're asking you to pull a part out of a whole compound, you must first convert the entire compound into what it's asking, which is moles, and then use how many of moles are in the compound. And that may sound confusing, but I'm going to explain it as I answer this problem. But always think from the thought process of deal with the whole, then I can solve for parts. So first, again, we have 60 grams of barium phosphate. But our final answer needs to be in moles. And so when we're treating the whole, we need to make sure the whole is in moles before you find the moles of oxygen, which is a part of the compound. So again, like you did in previous problems, you're going to use molar mass to convert this to moles. So you're going to multiply this by the molar mass that we found previously, which is 601.84 grams over 1 mole. When you're solving these problems, please write the units. Don't just write 601.84 because you're going to get confused later on down the road. You're going to be like, is that moles? Is that particles? Is that grams? What does that mean? And so always write your units. It's going to make your life easier. So we can cancel out our grams. But this is just going to tell us the moles of this entire compound. But that's not what the question is asking. It's asking for oxygen. So after we've converted the whole compound to moles, now we can focus on the part, which is oxygen. So when you look at this compound, how many moles of oxygen are within this compound? Well, we have 4 here, but there's 2 units of this polyatomic ion. So 4 times 2 is 8. So we have 8 moles of oxygen in this entire compound, meaning we can use a conversion factor of 8 moles to 1 mole of barium phosphate. So you multiply that by 8 moles to 1 mole. And so we can cancel out moles here, but our answer will still be in moles. And so this is a ratio that was pulled straight from this compound. We have 8 moles of oxygen per 1 mole of this entire compound. And so when you plug this into your calculator, you're going to get 0.79 moles of oxygen. And that is how you solve question 1 of part D. Remember, before you start focusing on the part, make sure the whole is in the same units as what the question is asking. So if they had given us moles right here, we wouldn't have to do any conversions and we can go straight to our ratio. But because our answer is in grams, we have to turn this into moles, then we can focus on the part. So whole, then part. I can't stress that enough. Okay, so for question 1, part E, it's asking us how many oxygen atoms are in 60 grams of barium phosphate. Now, many of you were able to do this problem with relative ease because, again, you're using numbers that you previously solved for in the questions that were above this. However, I'm going to work this out as if this was an entirely new question on the exam because, again, questions are not going to be attached to one another, meaning you're going to have to set up a very large dimensional analysis when you need to go from mass all the way to particles. So let's do that. So we're starting with 60 grams, so we're starting with mass, and it wants us to go to atoms. So that is a particle, meaning we're all the way on the left of the conversion sheet, and we need to go all the way to the right. Again, I'm referencing the PowerPoint slide that has mass, moles, and particles set up very nicely for you with the conversions in the middle. That is going to be your best friend. Try to internalize that conversion PowerPoint slide in your head. So all chemistry teachers have a slide with the conversion table. So we're starting with 60 grams. And you'll see this is why it's important to label things, because when it gets long, you want to label it so you know what everything is. We have 60 grams of barium phosphate. And if we want to go from grams to moles, because we can't just go straight to particles or straight to atoms, we have to go through the middle, which is moles. You're going to use, again, the molar mass of barium phosphate. And we already found that, but on the exam, you're going to have to find that for yourself. And we know how to do that. You can reference question number 1 over 1 mole. So that cancels out grams, so we don't have to worry about mass anymore. We're in moles. So this is going to give us an answer in moles. So what do we do now? We want to convert to atoms. But before we do that, we need to remember, what are we talking about here? We're talking about oxygen. And so we're not talking about the complete compound, but we're singling out oxygen. So let's convert this to focus on oxygen within this compound. So you're going to multiply this by 8 moles of oxygen, which is what we have here. Excuse me. 8 moles of oxygen per 1 mole of our entire compound. So now we're talking about oxygen because there's 8, 4 times 2 per 1 entire compound. So we're focusing on oxygen now. But it's not how many moles of oxygen, it's how many atoms. And so to convert this portion into atoms, we need to use Avogadro's number. So again, we cross out our moles. Our answer is now in moles, but we want to convert that to atoms. So we're going to use Avogadro's number. So you're going to multiply that by Avogadro's number. And so now you can see what we've canceled out. We've canceled out mass. We've canceled out moles, and we multiply it by Avogadro's number, which is going to give us the answer in atoms. And so if you plug this into your calculator, again, please put parentheses around scientific notation when you plug it into your calculator. You're going to get an answer that looks like this. 4.8 times 10 to the 23rd oxygen atoms. And so this is how you solve question 1, part E. You may not have solved it this way because of how the worksheet was set up, but if it was an entirely new question on the exam, this is the conversion you would have to do, right? So please write it out like this, because you're gonna get it jumbled into your calculator, and that way you can put this into a calculator, get a number, multiply it by this, get a number, multiply it by that, get a number, and so you can ensure that you get this question correct. These are easy points, but we ourselves can make it more complicated. You don't need to rush. Take your time, understand what the question's asking, and make sure that it's in the correct unit and we're focusing on the correct element or compound. For question 1, part F, it asks us, what is the mass percentage of phosphorus in barium phosphate? So percentages are just parts divided by the whole. And so it's just a ratio. And so we want to understand how much phosphorus is in this entire compound. And so we're talking about mass, and so you know that we're going to try to find the mass of phosphorus that is in this compound and the mass of the entire compound. And we know that the mass of the entire compound is just molar mass, and we solved that previously. And so remember, that was just 601.84 grams. Again, to solve for that, you're gonna do 3 times the mass number of barium, 2 times the mass of phosphorus, 8 times the mass of oxygen, and you're gonna add them together. Please again, refer to question 1 if you do not understand how to solve for molar mass. And now we wanna figure out, what is the mass of phosphorus? Well, how many phosphorus do we have in this problem? Again, remember it's not 1, we have 2 units of this polyatomic ion, so it would be 2. And so, similar to how you would solve for the molar mass, you're gonna take phosphorus, is 2 times its mass number, which can be found right underneath the element on the periodic table, and that is 30.97. And this gives you 61.94 grams. And so now you're just taking the part and dividing it by the whole to create the ratio. So 61.94 grams. And then you're going to multiply that by 100 to give you a percentage. And so your answer, if you round it or if you don't round it, it doesn't matter. It's a multiple choice exam, so pick the answer choice that is closest to your answer. It should not be 5 to 10 difference, but it should be a difference of maybe 1, maybe 0.1, something like that. Nothing very large, but a very small difference. And so you could get 10.3%, or you might have gotten 10.29%. Both of these are correct. Again, multiple choice exam. So again, find the part divided by the whole. It gives you a ratio. Multiply that by 100. You're going to get a percentage. It could have asked for barium. It could have asked for oxygen. This number is the only thing that's going to change. This is always going to be the molar mass of the entire compound. No matter what this question asks you for barium, phosphate, or oxygen, you're just going to change that top part to figure out the ratio of the whole. So that's how you solve question 1, part F. So here's how you solve question 2, part A. It tells us to calculate the empirical formula. So first, you want to translate, what does that mean to calculate something into its empirical formula? When it says empirical formula, it's talking about the simplest whole number ratio. So to memorize what empirical formula means, you can think about mathematics. And within mathematics, what is something that all math classes want you to do? Simplify. So we want to simplify our molecular formula, and you're going to do that from the mass percentages. Now, something to understand. Yes, they're in percents, but this adds up to 100, meaning we don't have to treat these as percents, okay? We can just call them the masses of each of these elements. So this would be 49.48 grams of carbon, 5.19 grams of hydrogen, 28.85 grams of nitrogen, and 16.48 grams of oxygen. And again, the reason we can do that is because those percentages added up to 100, so you can take them as direct numbers. So the next thing you're going to want to do is you're going to want to convert these masses into moles. We've already done that before, and you're going to use a conversion factor, which is their molar mass. So carbon's molar mass, or mass number, is 12.01. So again, you're going to divide it by 12.01 grams because we want to cancel out grams, okay? Hydrogen is 1.008 grams because you want to cancel out the grams. And this may look confusing, but let me show you exactly what I'm doing. I'm just not writing out all the work, but this is again dimensional analysis. And so what I'm really doing, I'll just write it over here for simplicity so that you can understand what I'm doing, right? We have grams, and we're just multiplying it 1 mole over 12.01 grams. This is what I'm doing, but I'm shorthanding it, but I'm still canceling out the grams and turning this into moles. So don't get confused. I'm using the molar mass or mass number, dividing it by the mass, which is going to give us moles. And so this is the setup if you wrote it out long form, but I'm just going to continue to write it like this, but that is what I'm doing. Nitrogen has a mass of 14.01 grams, and then oxygen has a mass of 16 grams. So when you plug this into the calculator, it's going to give you the number of moles of each of these elements. So for carbon, we're going to have 4.12 moles. I'll write it just so you can understand what everything is. For hydrogen, we're going to have 5.15 moles. For nitrogen, we're going to have 2.06 moles. And for oxygen, we're going to have 1.03 moles. So that's the percentages converted to moles. Now, when we're talking about empirical formula, you want the simplest whole number ratio. So out of all the moles, you're going to find the smallest one, and you're going to divide it by each of these values. So 1.03 is the smallest, so we're going to divide that by itself. So that's going to give you 1, because again, it's the simplest whole number ratio. So you're going to want 1 as your lowest number as a subscript. So you're going to divide that by itself. You're going to divide that by 1.03, and you're going to do the same for each of them. And this is going to give you the subscript for your chemical formula. So if you do 4.12 divided by 1.03, you're going to get 4. If you do 5.15 divided by 1.03, you're going to get 5. 2.06 divided by 1.03, you're going to get 2. And anything divided by itself is obviously just 1. Now, what do you see here? These numbers right here are very close to the answer that we achieved for their subscript. So you might have the habit to just say, this is close to 4, this is close to 5, this is close to 2, and this is close to 1. So that's the answer. But that's not always the case. Yes, it worked here, but do not make that mistake of just rounding these numbers to the nearest whole number, because there's going to be cases in which they're not really that close to a whole number. So this number could be maybe close to 5, but it's also close to 4. So do not do that. You're going to take the smallest amount of moles and divide it by all of the moles. And so then you're going to get each of the subscripts. So then when you write out the chemical formula, you're going to have carbon 4, hydrogen 5, nitrogen 2, and oxygen. So that is your empirical formula for this compound. So now for question 2, part B, it's asking us if the molar mass is 194.19 grams per mole, what is the molecular formula of C4H5N2O? So this right here is our empirical formula that we solved in part A. So now we want to know what is the molecular formula of this. So we're not looking for the simplest whole number ratio, but we're looking for the number that we can multiply each of these subscripts by to find the original molecular formula that is connected with this molar mass. And so to solve these problems, this is the formula that you want to set up. So it's going to be molar mass divided by the empirical formula mass. So we want to find the molar mass of this compound and divide it by the molar mass of the original compound. And that's going to give us a number, because essentially these are a ratio between one another. And when we find that number, we can take it and multiply it by each of these subscripts so that we can figure out the molecular formula. So if we already know what the molar mass is. So the molar mass is 194.19 grams per mole, okay? Questions in the exam are going to give you the molar mass. So all you have to do is figure out what is the empirical formula mass. And that might sound complicated, but it's simply just finding the molar mass of this compound, and we already know how to do that, right? So let's just set it up. For carbon, there's 4 of them. So for carbon, there's 4 of them. Carbon has a mass of 12.01, okay? And we know that there's 5 hydrogens, so 5 times the mass of hydrogen, which again is on the periodic table. These numbers on the periodic table, 1.008. And yes, you're going to get a periodic table for the exam. Nitrogen, there's 2 of them, and the mass of nitrogen is 14.01, I believe. And then you have oxygen, which again, we just have 1 of them. You don't show a 1 subscript times 16. Okay? So you're going to solve for each of these. Simply just plug it into your calculator, and when you do so, you're going to get various numbers that will add up to give you the empirical formula mass. And so just for time's sake, I'm not going to do this math right now, but if you multiply these out, you're going to get some numbers, and you're going to add them up together. And the number you get is going to be the molar mass, so it's going to be in grams per mole, and it's roughly 97.1, something like that, grams per mole. So again, just plug this into your calculator. Don't try to do any mental math. There's no need for any of that. However, for my pre-med students, these are common questions on the MCAT. In the MCAT, you do not get a calculator. And so there's some tricks that you can do. I won't show that now, but that's just to prepare you for what's to come. And the answer you'll get is roughly 2, but you're going to round that to 2. Okay, it's not going to be exactly 2, but it's going to be like 2.00158, something like that. And it's going to be very close to 2, so we know it's 2. And so then you're going to take your empirical formula and you're going to put a subscript of 2. And then you're going to distribute that 2 to each of these subscripts by multiplying. So what this comes out to is when you multiply each of these, you're going to get C has 4 times 2 is 8. H, 5 times 2 is 10. Nitrogen, 2 times 2 is 4. Oxygen, 1 times 2 is 2. And so this is your molecular formula. So if you solve for the molar mass of this compound here, you're going to get the number of 194.19 grams per mole. And this is how you solve question 2, part B. Question 3, part A says, what is the molarity of a magnesium chloride solution if 25 grams of magnesium chloride is dissolved in water to make a 0.5 ml of solution? And they provided the molar mass of magnesium chloride, which is 95.21 grams per mole. This is common on the exam. They will sometimes give you the molar mass, but again, we already know how to solve the molar mass, so don't worry about that. If they don't give it to you, you should know how to solve it. It's just gonna add an extra step to this problem. But first we need to understand what is molarity. So molarity is just a fancy scientific word for concentration. And so molarity is equal to moles of solute, what is being dissolved in the solution, divided by liters of solution. So we first need to identify what is the solution and what is the solute in our question. So it says, what is the molarity of a MgCl2 solution if 25 grams of MgCl is dissolved in water? So this tells us the grams of solute, and water is our solution, and we have a 0.5 ml solution. So if you look at molarity, it's moles over liters. And so we have grams and ml. So we're already in a position where we must convert. So let's start with our solute. Let's convert 25 grams to moles. Again, that's very simple. It's what we did previously. Yes, it's in a different context, but do not overcomplicate this. It's still the same methodology. Okay, 25 grams of MgCl2. And we're going from grams and we want to go to moles. You're going to use what as the conversion factor? Molar mass. An easy way to remember that. Molar mass is always in grams per mole. So if you have grams and you want moles, or vice versa, you're going to use molar mass. So we want to cancel out grams, so the grams for the molar mass is going to go on the bottom. It's going to be 95.21 grams per 1 mole. Okay, so this is the setup. We cancel out our grams, and our answer will be in moles. And the answer that you'll get if you plug into your calculator is 0.262 moles. Okay? So we can plug that into the top part of our equation. Okay? But we were given the solution volume in ml, not in liters. So what do we do, right? And just to fix this really quick, the question wasn't 0.5 ml, it was 500 ml. And so we need to convert 500 ml into liters. I'm going to set up the conversion just so that you can see, but you should be able to convert between liters and ml very quickly without having to set this up on your paper. But for just sake of this problem, I'm going to do it. So how many liters or how many milliliters are there in liters? If you don't know, there's 1,000 milliliters in 1 liter. And so you'll write 1 liter over 1,000 milliliters. And dividing by 1,000 is simply just moving the decimal point over 3 times. So you're going to get 0.5 liters. So now we know what to put on the bottom. We have moles of solute and liters of solution. So 0.5 liters. And when you plug that into your calculator, you're going to get 0.52 molarity. And that is how you solve question 3, part A. Remember, when you get to the exam, read the question, identify units before you start plugging things into your calculator, because if you don't, you're going to get an answer choice. And I guarantee you, there's going to be an answer choice that just simply divides 25 by 500. And you're gonna end up circling that answer choice. But remember, convert and then answer the problem. Because this is testing not just your ability to get the correct answer, but it's your ability to understand. If you understand that molarity is in moles and liters, you'll never get the question wrong. But if you don't understand that and you're just working like a robot, you're gonna end up just dividing 25 by 500. So that's how you solve question 3, part A. For the final question, question 3, part B, it asks us, what is the molarity of chloride ions in the MgCl2 solution that was in part A? And so again, because these questions are connected, they may be a little easier. On the exam, questions are not connected. Each question, you're going to be given a different scenario, and so you're gonna have to work out a lot of components to get to the answer that is being separated on this worksheet, okay? But for this problem, I'm not gonna rework out how to do the molarity. But to solve this on an exam, you're gonna have to do part A and part B simultaneously, okay? So what is the molarity of chloride ions in the MgCl2 solution that was in part A? So let's just quickly remember the molarity that we solved for in part A, which is, again, moles of solute, what is being dissolved, divided by liters of solution, was 0.52 molarity, but that's the entire compound of MgCl2. We're talking about chloride ions now. So again, remember previously I talked about when you're working through problems in chemistry, especially for Gen Chem 1, when they ask you things about something that is a part of an entire compound, make sure you solve for the entire compound and then you can solve for the part. And so it's asking for molarity, so you want to find the molarity of the entire compound, which is what we did in part 1, 0.52 molarity. Now we can go in and extrapolate chloride ions. So something I always want you to do when you're given a question like this and they want you to figure out the molarity of ions in a solution, break up this compound into its parts as if it was being dissolved in the solution. And so what do I mean by that? You have MgCl2. If you put that in water in a solution, you're going to get Mg plus Cl. Now, what's the charge of magnesium? It's in group 2, so we know it has a +2 charge. And what is the charge of Cl? -1. Is this balanced? 2 positive charges to 1 minus charge. So it's not balanced. And so the way we would balance this is we would put a 2 in front of chlorine. So now we have 2 minus charges and 2 plus charges. So the charges are 0, or a net charge is 0. So now, if we look at this, when you're in a solution and you dissolve magnesium chloride, you're going to have 2 chloride ions. And so if it's asking for the molarity of chloride ions, the fast way to do this is just take the molarity of the entire compound, which is 0.52 molarity, and multiply that by 2. And you're going to get an answer of 1.05 molarity of chloride ions. The reason you can just multiply the compound's molarity by 2 is because you're in the same solution. And for this specific class of Gen Chem 1, you're always going to be in the same solution for majority of this course. And so you can just simply figure out which compound or which element we're referring to, or which ions they would like to see, or that the question is asking for, and you're going to multiply the compound molarity by the amount of that element. So if this would have asked for magnesium, we would remove this 2 and put 1 because there's only 1 magnesium ion. So that's how you figure out molarity of ions. And that concludes the peer leading activity number 2. If you're in my peer leading class, please reach out on the GroupMe if you have any further questions. You can fast forward the video, go to specific questions, watch it over and over again, because again, the exam is going to be similar questions, right? They're going to change some numbers, change some wording, but for the most part, your peer leading activities are great resources to prepare you for the exam. There's also weekly worksheets that are within your module course, and I also recommend that you work through those weekly worksheets as well. Good luck on the upcoming exam, and that is the conclusion of this video.